Okay guys, I just got on. I have been waiting for 10 minutes. It's been driving me crazy. I'm just going to load the pages and we'll be ready to go. I hope you've all run your audio checkup, audio wizard, just to make sure. I'm just going to, as soon as the PowerPoint's loaded, then I can let you have your tools and stuff too. All right, so you might need a calculator this week. Again, this unit is not about knowing whether you know your times tables or not. This unit that we're starting right now is area. So I thought I'd put on a wishful thinking. I wish this is what our winter was looking like. Instead it's raining out there again. So hopefully we'll get some winter in the next week or so. I'd sure like that. Anyway, we're going to move on. It's 4:06. Sorry that we're late starting, and I'll try and make it a little shorter. So we're going to be learning how to calculate the area of two-dimensional figures. What is a two-dimensional figure? Can someone tell me? And I've set this so you can use the, when it is flat, that's good. That's actually a really good way to describe it, Stephen. I've opened up the microphone too for you guys that want to answer just with your voice. But yeah, it's a flat, it's a two-dimensional figure, has length and width. It doesn't have depth. So a cube has 3 dimensions, but a square has 2 dimensions. So we are going to be learning in the next little while, and these aren't hard formulas at all, but we're going to be learning how to figure out how much space something takes up. All right? So when we're talking about measuring the space of something, and you can't measure it with a straight line. So I can't look at my desktop where I'm sitting and say, oh, that is 3 meters. It isn't, because it actually takes up more space than just a 3 linear meters. So we have to figure another way to do it. So the top of your table in the kitchen is the same. So you can say that it has length and width such as 4 meters wide, or 3 meters wide and 4 meters long. The space taken up by the table is calculated in units squared. So for example, if it's the length times the width equals the area, and that's what we know is our area. Anybody want to argue with that one? I don't. This is stuff that's just a reminder from grade 6. So we know that length times width, just a second, let me see if my mouse is working. Oh, it is, that's great. Length times width, does that look like it was writing, equals area. All right? And that area is always in units squared if we're doing length times width. So what is that the area of when I'm doing length times width? The top of the table. The top of the table. So what do we say that we measure length times width equals area? What kinds of figures is that for? William says it's squared. We can use it for a square, that's for sure. What about a rectangle? Can we use that for a rectangle? Yeah, we can. So 4-sided figures that are not parallelograms, because those are a different sort of thing altogether. But our rectangles and our squares can all be having the area measured by doing length times width. Right, so that's a pretty easy one. And we always have to remember to put that squared. That's super important because that shows us there's 2 dimensions. Okay, so we can't say that it's 12 meters because 12 meters is probably the distance from here to Mrs. Botter's room, but it isn't measuring area. All right. So we're going to, before we move on to new concepts, we're going to calculate the areas given below. So how about a patio that measures 6 meters long and 5 meters wide? What is the area for that? Oh, look at that. William's fast. William's a fast reader. Do people agree with William? It is actually 30 meters squared. 6 times 5 is 30, and because we have meters times meters, we remember that's 2-dimensional, so we put the little square there. So it's 30 meters squared. Excellent. I'm just going to write that on here because some people, when they watch, they don't get to see your chats. 30 meters squared. Okay, this one you might need a calculator for. A swimming pool that is 25 meters long and 15 meters wide. Oh, Jasmine's fast. Look at that. And Manmeet. These guys have got their calculators out already. So 25 meters times 15 meters equals 375 meters squared. That's excellent. So we would say that the area that that takes up is 375 square meters. All right. And there's another bit of my excellent writing. A quilt for a bed that measures 1.2 meters wide and 1 meter long. So it's 1.2 times 1.0, which Jasmine and then we got a little bit off. It is 1.2 meters squared. Remember, the number multiplied by 1 is itself. All right. So a problem, we're going to deal with this one later, so you don't have to do this right now. A problem that you might see is this one. So there's an area of the deck around a pool. The pool is 10 meters wide and 6 meters long, and the deck is 2 meters wide around the entire pool area. So draw and label a diagram to figure it out. So this is what I would do on this one. Let's stop using the funny sun. I draw this diagram. Notice that it almost looks like I know what I'm doing. That was just a total fluke. And then I do this, and I draw around it my pool deck. All right? Now, I know that the pool is 10 meters wide, so we must be looking at this the wrong way, 10 meters wide and 6 meters long. That should have been the other way around. That's fine. All right. So we know that the area of the pool is what? What is the area of the pool? It is 6 times 10, which equals 60 meters squared. Excellent. That's what Stephen says. Now, what does it become when we have this 2 meters here and here as far as the length? Can someone tell me now what the 10 meters becomes with the 2 meter deck on it? It's 14 meters, says Jasmine. Excellent. Now, what about the other distance? Here and here we have to add some stuff too. So what are we adding there? It started at 6, so now it's by 10. All right. So what is the area of the pool and the deck? All together. Would it be those two together? Yes, Mrs. Fair, it would. So, thanks, Stephen. So it becomes 140 meters squared. How do I figure out the area of the deck here? Anyone have an idea? So we have an area of the pool, and we have the area of the pool and the deck. So what am I going to do? You can use a microphone if you want. Manly's going to subtract. She's a smart girl. Take away the pool area, says Jasmine, and that's what we're going to do. So we start out with a mouse jumping all over the place. This is not, hopefully you guys aren't hearing me like Minnie Mouse too, because that'd be the worst. So we take 140 meters squared, and we subtract our 60. Notice I'm not putting the units until I got my answer. And so my answer is going to be 80 meters squared. That is the area of the deck. So in lots of the questions that they're going to ask you when we're doing this kind of work, they're going to ask you to think about and draw a diagram and label what you're doing. Because quite often when you do that, it becomes super easy. But if you were thinking about this problem, it might not seem as easy as all that. So it's just, for me, it makes sense when we're doing two-dimensional geometry that you guys actually start drawing some pictures. They don't have to be perfect. I know I look, mine's perfect, but you know, yours doesn't have to be that good. Anyway, we're going to move on. So the area of a parallelogram is a little bit different. All right? So let's think about this for a second. I'm going to draw a line. I hope I'm going to be able to do this. Oh, look at me. What is that line, if it had stopped where it's supposed to? Get out of there. Okay, I'm going to just delete that and try again. looking pretty good. What is that line going to represent if I can actually draw it? I'm coming from the corner, and I'm drawing a straight line right down to the base. What does that represent? Does anybody know? That is your height. All right. Now, why didn't I just measure from the top to the bottom? Any thoughts on that? Henry's thinking something. Why didn't I just measure any? Oh, because it's not straight. So what we're trying to do is figure out, okay, what is the actual height of this figure? So we draw a straight line that comes down and it connects to the base, and this is the really important part. It connects to the base at a right angle. So you can form a square coming off of it. And then this is the height. Okay? So you can see area of all parallelograms can be measured by multiplying the base times the height. The right angle for measuring the height is always drawn from the baseline and has always got a right angle. Okay? So on this one, what are we going to do? Okay. It's not straight. So we're going to draw that line for the height at a right angle. Is that one going to work? No. Is this one going to work? How am I drawing that line? Does anybody want, if I give you the pen, I want some people to show me how they're going to draw that line if that is the base. Just let me clear the page so that my lines are gone. I'm going to give you the pen. Please don't scribble out the page. So you can draw the pen and just try yourself. Draw a line on this one, the second, and I'm going to put the sun on it. This is the one I want here. So take the pencil, and if you're using a mouse, if you just hold it straight down, it'll draw a straight line. See if you can draw a base height. Where might that be easiest to do from? Does the base always have to be at the bottom of the page? Stephen, what's up? Did you just get in, Stephen? Would it be easier to draw this as your base and have it at a right angle? That's your height, and then your base would be this. So it doesn't matter which side is the base and which is the height as long as you do it the same way. Okay? So I'm going to give you some time to practice that. Just give me a second. Here's a new page. So get your calculator out. This is, I'm giving you, I'm not going to make you draw them. You're going to have to do that in class. You're going to have to measure them from actually using a ruler. But I've done that for you in this case. So what is the area of the parallelogram that is 2.75 centimeters and along the base and 3.9 centimeters in height? So figure that one out. And then when you're done, you can either send me the answer or you can write it on the page. Everybody's a little scared to use the pen. That's funny. Okay. I'm not getting anything from you guys. Oh, just a minute. Here's some coming through. Okay, now they are. Okay, so someone says 10.725 centimeters squared. That's very good. But we rounded that. So 2.75 times 3.9 became 10.725 centimeters squared, and that's really important that we remember that. 10, well, that's just drawing lines, that's just weird. Okay, let's try this. Oh, there we go. 10.275 It's one of those days today where nothing quite works. 10.275 centimeters squared. Now, cleverly, someone rounded that because they saw that the most that we had was 2 decimal places. So they just said that was 10.73, and it was rounded, and that's fine too. Would you get marked wrong for either of those? No. So there's the first one. The next one is decimal 8 centimeters along the base and 2 centimeters along the height. So what will we get there? For some reason, there's a delay on your answers coming in a little bit. Van Reed got that quickly. Oh, look at that. Jasmine's fast. 1.6 centimeters squared. Now, I don't care if you use your calculator. You probably don't need to for a lot of these. The next one, 24 centimeters times 9 centimeters. Oh, Man Reed and Jasmine are fast. 24 times 9 equals 216. And the next one, trickier. Let's think about this. We did some of these kinds of things when we were doing percentage. We have what the total is, and we have what 1.2 centimeters times some number of centimeters, and then the other one, which is, I have to see if that's actually blocking my view, 27 meters times some meters equals 54 meters. So if we can't multiply because we don't have the answers that are right there, what can we do? We can divide, says William. So we did 3.6 centimeters squared divided by 1.2 centimeters, and that is 3 centimeters. Okay, 3. So then you can check that by checking your multiplication. 1.2 times 3 is 3.6. And the last one, 54. 54 divided by 27 equals 2, says Zainab, because she's smart as a whip. 2 meters. So 27 times 2 is 54. So again, just like we did with percentages, if you go backwards, then you just have to remember when you would have multiplied, now you divide. All right. Now, here's your homework, and I want you to draw a picture of this because I want you to practice this. Calculate the surface area of the swimming pool that has a length of 12 meters and a width of 7 meters. And then what would the area of the pool and deck be if there was a 2-meter wide deck around the whole pool? And then you can tell me if you want to for bonus marks, because I know some of you care about this so much, is tell me how much the deck is. So at least give me the pool and deck, but if you're really clever, you can give me the deck too. So now I'm going to ask you to copy this down and go. I'm really sorry I was 3 minutes late coming on, but it was just the delay with the computers today. It was a little frustrating. Hopefully it'll be better tomorrow. And make sure you copy this down and then you can go. Bye, Zainab. See you, Stephen. Thank you. Bye, Manry. Bye, William. See you, Lexi. Oh, just let me look. I will look up your, you should have gone back today, but we just ended up, the math test took us so long. But if you hang on a second, I'll look up your test mark for you. Hang on. Did you say something? Oh, bye, Jasmine. Stay on a second, Lexi, and I'll tell you. Maybe I'm flipping papers like a mad fiend. I'll type it in so I'm not announcing your test mark to the whole class, even though it's fabulous, because that's not a good way to do things. So I'm going to type it in here, and then you figure out your percentage, okay? That doesn't actually show on the class. Have a good night, Lexi.
Jonathan, if you are in the building, could you please come meet your mom down by the office? Jonathan, Angus, please. Meet your mom by the office. Thank you.